Hi students, welcome to physics class. I'm your physics teacher Pranav. Okay, today we are going to discuss about our first chapter, that is forces in fluids. Okay, let's see what is Pascal's law. Okay, excavators are meant to help in disaster management and environmental protection, but it is now using for raising hills and filling up paddy fields. It's a common sight now, isn't it? In our childhood, it is wonder that how this machine works, isn't it? Okay, let's see. While taking toothpaste like this, while we pressing any of the point of that toothpaste, the paste come out, isn't it? Yes, the paste come out while pressing at any point of the tube. Also here we can see a sponge bowl. This sponge bowl contains water. If we are applying a force or a pressure at any of the point of that bowl, the water comes out through every point. Look at the picture. Okay, let's see a video. It is demonstration of Pascal's law. Okay, Pascal's law states that when pressure is applied at a point containing fluid which is at rest, it will transmit equally at all directions. Okay, here we can see that a football. Now take a system. This system has 4 openings. We can see that in the picture. Okay, the openings can be named as A, B, C, D. Also, these openings have a pistons. Okay, it is namely P, Q, R and S. Okay, now see what happens if we are applying a force at one end. See, while we applying a force at any of the end, what we can see, the other pistons are moving outward. Okay, now we are filling water in the system. Okay, now pressing C. The other pistons are moving outward. Okay, how it happens? How it happens? Let's see what the Pascal's law says. The Pascal's law states that the pressure applied at any point of a liquid at rest in a closed system will be experienced equally at all parts of the liquid. Okay, when we are applying a force in a liquid which is at rest in a closed system, the pressure will experience equally at all the direction and all the points inside the system. Okay, there are some devices are designed on the basis of Pascal's law, which are the hydraulic brake of vehicles, hydraulic jack, hydraulic lift, and hydraulic press. Okay, we are using hydraulic jacks in the service stations to lift the vehicles. Okay, let's see what is hydraulic jack. How it works, the theory behind the hydraulic jack. We know that the equation for pressure, okay, it is pressure is equal to force divided by area. Okay, force divided by area. We can write it as P is equal to F by A. Okay, now consider a closed system which contains a liquid. Okay, the system has 2 ends. Okay, the system has 2 ends. Okay, it is better to see here. Okay, this is the system. It has 2 ends. Okay, the area of cross section of the first end, you can see here. Okay, we can name it as area A1. and the area of the second end is namely A2. The area A2 is 10 times more than the area of first end. Okay, clear? The area of second end is 10 times than the area of first end. Okay, and the force applied at the first end, we can take it as F1, and force experienced at the second end, we can take it as F2. Okay, we know the equation for pressure, that is P is equal to force by area, that is F by A. Okay, remember that F by A, pressure is equal to force by area. Okay, the Pascal's law says that the pressure inside the closed system which contains a liquid at rest will be equal at all points. Okay, Pascal law says that the pressure exerted at any point of the liquid will spread all over the liquid equally. Okay, the pressure will spread all over the system equally. Okay, suppose we provide a force at the first end, the pressure P1. Okay, we are providing a force at the first end. Okay, we can take it as P1, and the equation comes as P1 is equal to F1 divided by A1. Okay, remember this equation, P1 is equal to F1 divided by A1. Okay, this pressure will transmitted to the second end. Okay, thus the pressure experienced at the second edge will be P2 is equal to F2 divided by A2. F2 means pressure experienced at the second end, and A2 is the area of cross section of the second end. Okay, that means pressure experienced at the second end is equal to force experienced at the second end divided by area of second end. Okay, the pressure at both edges are equal. Okay, from the Pascal's law, it is clear that the force or the pressure is equal at the all point. That means the pressure at the first end and the second end are the same. Okay, that means P1 is equal to P2, isn't it? It's come so. P1 is equal to P2. That means the right hand side is also equal. That is F1 divided by A1 is equal to F2 divided by A2. Once again, it is an important equation from this part. Okay, F1 divided by A1 is equal to F2 divided by A2. We have to remember the terms. That is, F1 is the force applied at the first end, A1 is the area of first end, and F2 is the force experienced at the second end, and A2 is the area of second end. Okay, consider an example. Consider the area of first edge is 1 square meter and the area of second edge is 10 square meter. If we apply a force of 1 Newton, note that if we apply a force of 1 Newton, how much force will be experienced at the second end? Okay, let's see. Given that A1, the area of first end, A1 is 1 square meter. Okay, A2 is the area of second end. Okay, A2 is equal to 10 square meter. Force applied at the first end, that is F1, is equal to 1 Newton. Okay, we have the equation F1 is equal to, F1 by A1 is equal to F2 by A2. Okay, now we are applying these values to the equation. That is 1 divided by 1 is equal to F2 divided by 10. We have to calculate F2. Okay, we have to calculate F2. So keeping F2 here, that is after rearranging, we got F2 is equal to 10. How? We are keeping F2 here taking this denominator, that is 10 to the left side, that is 1 into 10, that is equal to 10. That means F2 is equal to 10. That is, we got F2 is equal to 10. The answer, the force experienced at the second end. Okay, by applying a small force at one end, we got 10 times, okay, of the applied force. Okay, do you note the point? That is, by applying a small force at one end, we can get a high force or more force at the second end. This is the working or the theory behind the hydraulic jack or hydraulic lift. Okay, these are some activities for you. Okay, calculate the force experienced at the second edge of a hydraulic lift. If we apply 5 Newton force at the first end and the area of the edge is 2 square meter and that of the second edge is 10 square meters. Okay students, these are 2 questions for practice yourself. Okay, we will meet in the next class. Okay, thank you.